Okay, pre-calc, let's go ahead and take a look at a review of everything that we've done so far. So the first thing I want to talk about is area of a sector. The area of a sector is a piece, okay? So the area is a fraction of the entire area of the circle. So I need to know what the angle is right here. Okay, so the area might be degrees. If it was 70 degrees out of a total, how many degrees are in a circle? 360. And that would be times pi r squared. Okay, if the angle was given to in radians, for example, maybe pi over 3, that's pi over 3 radians out of how many radians total in a circle? 2 pi. Times the area, which is pi r squared. Okay, I think just thinking of it as a fraction of the area or a fraction of the circumference makes less formulas for you to memorize. Now, of course, this pi would cancel with that pi and things would cancel, or you could just strictly type it in. Okay, when it comes to arc length, okay, we're talking about this arc right here. That is a piece of the circumference of the circle. We still have to know from the center of the circle, okay, what the angle is. So arc length has letter S, and that's a fraction of the circumference of a circle. So if I told you this angle was 70 degrees, that would be 70 out of 360 times 2 pi r. If the angle was given to you in radians, then it would be pi over 3 out of a total 2 pi times 2 pi r. Okay, so it's a fraction of the entire circumference, or it's a fraction of the area of a circle. Okay, the three ways that I want you to think about revolution. Okay, one revolution. You could go around a circle. Okay, how many degrees is that? Yeah, 360 degrees. Okay, now I want you to go one revolution, one time around a circle. How many radians is that? 2 pi radians. So this was degrees, this is radians. The other one, the last one, which I think is helpful sometimes, is length. So if you go once around a circle, how long is it? 2 pi r and then units. So sometimes it's inches or centimeters, but that's the circumference. Three different ways to think about one revolution. Some other things you should know. DMS. What does it stand for? Degrees, minutes, and seconds. And you should know where the DMS button is in your calculator. RPM, a lot of times the word problem will say, what is the RPM? And that's revolutions per minute. How many revolutions around a circle is it making? MPH, anybody that drives a car knows this. Miles per hour. Okay, so if abbreviations are given in a problem, you have to know what they mean. If you want to, you could use those in your answers as well. Okay. The next thing we're going to do is use our calculator. So I want you to take out your calculator and I want you to type this into your calculator, but I want you to convert it to degrees, minutes, seconds. So we're going to type 71.315. Okay, go find your degree bubble. Okay, and we're going to convert to DMS. So your answer is going to have degrees, minutes, and seconds. No, go ahead, please do it. Pause the video, and I want you to calculate this. Okay, do you have your answer? Let's check and see. First of all, I know it's 71 degrees because that was the problem. The angle's not going to change. We're just writing it a different way. But instead of 0.315, the answer is 18 minutes and 54 seconds. Is that what you said? Okay. As well, I want you to use your calculator to take degrees, minutes, seconds, and change it into decimals. So all you have to do is type this in exactly like you see it. Where do you find the bubble and the minutes? It's in the angles command, yes. What about seconds? That's not in the angles command, that's somewhere else. That's on the front of your calculator, right? Using the alpha button. Okay, so type this in, and the answer is going to be 47.26. Now, if you write that, you're going to get it wrong. Okay, you have to put a degree bubble. Without degrees, you're saying radians. So let's just put a little note here, okay? Must include degree bubble. If you have any calculator questions, make sure you ask in class how to work your calculator. Okay, here's an example, and it says find the exact length of arc CD. So the arc is going from C to D. Here's the arc. Okay, sometimes they want us to find the big arc. Do we know the angle that this sector has? Okay, and it's 70 degrees. So to do arc length, we're going to do S, little curvy S, kind of reminds me of the circle. And it's a piece of the circle that's 70 degrees out of how many? 360. 70 out of 360. And then this is the outside edge, that's circumference, which is 2 pi r. And the radius for this problem is 6 centimeters. I'm sorry, meters. All right, now it says exact, so we're not going to type this in our calculator. We're going to try to get an exact answer, a fraction answer that's perfect. So can we cancel anything? Well, I know that we can cancel this 0 and this 0, first of all. A 6 can cancel with a 36. That becomes a 1. That becomes a 6. Sometimes it helps people to see what's left because it's getting a little confusing. 7 over 6. And then I still have 2 pi in the numerator. Well, 2 and 6, I notice, can cancel, making 1 and 3. So the exact arc length is 7 pi over 3 meters. Okay, when it says exact, they don't want you to type it in chop. You're going to have pi in your answer. Okay, let's take a look at some word problems. Okay, whenever you have word problems like this, the easiest thing to do, okay, is a conversion chart. The first thing I need to see, though, is a circle. So we're going to draw a circle for this problem, the diameter of a wheel. Okay, so what you have to be super careful of right away is when they give you the diameter that we label the radius. The diameter is 20 inches, so the radius here is 10 inches. Be careful of that diameter given. Okay, you're traveling at a speed of 15 miles per hour. Okay, what is the RPM? Okay, so I've got my circle, step 1. Step 2, let's write our goal. They gave us 15 miles per hour, and they want me to convert that to RPM. I have to know what that is. RPM stands for revolutions per minute. So there's our job. Miles into revs, hours into minutes. Okay, the best thing to do is to start with a conversion chart with what you're given. So we're given 15 miles per hour. Okay, and now it's your choice if you want to start working on the hours or the miles. Most people say let's work on hours because that's easy. Let's get that taken care of. Hours have to go away and I have to turn it into minutes. If I want hours to cancel, I'm going to put hours on top. Do I know hours directly into minutes? Yes, 1 hour has 60 minutes. Cancel, cancel. Now I've got the minutes. Okay, check. Minutes are done. Now I've got to work on those miles. Okay, a revolution means 1 time around the circle. Okay, so let's go look at the circle. 1 time around this circle. This circle is in terms of inches. I've got miles. So I'm going to have to change mile into inches if I want to talk about this circle. Okay, so I know miles have to cancel out. So I know miles are going to go in the denominator. And then miles are going to get changed into, I don't know inches. What's the next unit that we know? Feet. Okay, 1 mile. You always put the 1 on the big one. 1 mile is how many feet? 5 tomatoes. 5280 miles. You're gone. Okay, but we have feet. We don't want feet. Looking at this circle, for me to talk about the revolution around this circle, it needs to be inches. Okay, so if you want feet to cancel, feet are going to go down there. And I can go from feet into inches. What's bigger? 1 foot has how many? 12 inches. Okay, feet, you're now gone. Is that what we wanted, inches? No, we wanted revolution. Revolution. 1 time around this circle. Okay, but I do have inches. So I know inches are going to go in the denominator. And 1 revolution. 1 time around the circle, 1 revolution, okay, in terms of inches, is the circumference in terms of inches. Okay, it's not 360 degrees. I want inches. Inches. Okay, so 1 revolution is how many inches? 2 pi r. 2 pi 10 inches. Inches cancel, and now we've got revolutions. Okay, we've got revs, we've got minutes, we've done everything. All we have to do now, okay, is type everything on our calculator. Anything in the numerator, okay, is times. Make sure we divide by both of these things. I really want you guys to try this in your calculator. Okay, I want you to get an answer that is revs per minute. Revs per minute. Go ahead and type it in, please. Let's just make sure we got it right here. 252.10. How did you do? Good, I hope. Okay, I really hope you're playing along with me. All right, let's keep going. Here's another type of word problem that we did. Okay, we've got Charleston, which has some north latitude, and then we've got Jacksonville. So when we draw our circle, okay, the circle's actually representing the Earth. Okay, and somewhere on this Earth, we have 2 cities. Okay, so we have 1 city, okay, right here, Charleston, and it's due north of Jacksonville, Florida. Okay, so it's due north on the Earth. Okay, but since the Earth is round, okay, when it says find the distance, that's actually the arc length. It's actually a curvy part of the Earth that we have to find. Okay, this could be 3-dimensional actually coming out at you. Okay, so since this is arc length, we're going to go with S equals angle out of 360 times 2 pi r. Okay, so let's take a look at the angle. Do I know the angle here? I know Charleston has this north latitude, 38 degrees 21 minutes, so that would be his measurement. And then Jacksonville, Florida has this angle, okay? But to find the angle between them, I'm going to have to subtract. And I'm just going to type all this in at once. So we're going to do 38 degrees 21 minutes minus 30 degrees 20 minutes out of 360 degrees. And then the circumference of the Earth is 2 pi. How about the radius? The radius of the Earth is approximately 3,960 miles. So since we have miles here, our answer, okay, is going to be so many miles. Okay, we're going to type this in with a fraction. Make sure you hit times. Okay, go ahead and type that in, and then when we meet tomorrow, we'll check our answer. We'll check tomorrow. So I need you to play along a little. Okay, let's do the next one. I'm helping you with the setup. You're going to finish them off. An object is traveling around a circle with radius 7 feet. Okay, step 1 is always draw a circle. It's traveling round and around the circle. The radius of the circle is 7 feet. They didn't try to trick us with diameter. In 9 seconds, the object travels 3 feet. What is its angular speed in radians per second? Okay, so they want us to change this to radians per second. What were we given? It's got to be distance over time. 9 seconds, 3 feet. So that means it went 3 feet in 9 seconds. So they gave us feet per second, and they want us to change it into radians per second. I think the best way to do this would be with a conversion chart. Okay, so we were given 3 feet per 9 seconds. So seconds is already seconds. All right, we don't need to do anything with that. We need to change feet into radians. Okay, so feet, where do you got to go? Feet's got to go in the denominator. When I'm looking at this circle in terms of feet, let's talk about a circumference of a circle. So that would be 2 pi 7. Okay, so feet are gone. That's a circumference. What's the word that I could use for once around the circle? How about a revolution? Once around the circle is 2 pi r. Okay, but I don't want revolutions. I wanted radians. Okay, so thank you, revolutions, for helping. Revolutions has to get turned into radians. And this is just a fact. This is a fact. 1 revolution has how many degrees? 360. 1 revolution has how many radians? 2 pi radians. That's kind of tricky when you have angular speed. Done. So revs cancel. We have our seconds and we have our radians. So survey says so many radians per second. All right, go ahead and type everything in and we'll check the answer tomorrow. Okay, last one. Find the area of a sector. Find the area of a sector of a circle. Okay, let's draw a circle. A sector is like a piece of it, like a piece of pie. The radius is 17 meters. And the angle is pi over 4. There's no degree bubble, so this must be radians. Looks like radians. And it's pi over 4. Okay, to find an area of a sector, the area is a fraction. It's a fraction of the entire circle area. Is it a fourth? Is it a half? Oh, it's a fraction. Okay, so the area is going to be what fraction? It's some sort of angle. It's pi over 4 out of the total. This is radians. What's the total radians in a circle? 2 pi. Okay, and the area of this circle would be pi r squared. And the radius in this case is 17 squared. Okay. Maybe we should do this one exact. Everybody knows how to type it in, but let's work on doing it exact. So let's see. This pi can cancel with this pi. And so now I've got area equal to, this is pi over 4. You know, instead of doing a triple decker, instead of saying divide by 2, I'm just going to say 1/2. That cleans that up. And then we've got 17 squared. Okay, so the final answer. Does anyone know what 17 squared is? 289. The denominator is going to be 8. And then we can't forget our pi. And the units for this one would be meters squared. Okay, if you wanted to know the decimal, you could just type all that in. Nice. Okay, so can you find the length of an arc in the area of a circle? Okay, and can you do unit conversion techniques? And don't forget to show me these 2 answers tomorrow. Thanks, guys.